Astronomers combine the power of the Hubble Space Telescope and the James Webb Space Telescope to confirm that there are no giant planets in the well-defined disk that surrounds Vega, one of the most well-known stars in the sky. Vega, in the constellation of Lyra, is very close to us, and it is the second brightest star in the northern sky, close to the North Celestial Pole. In the 1950s, Vega became a critical star for modern astronomy thanks to the astronomer Harold Lester Johnson, who introduced three special filters known as the ultraviolet, blue, and visual, or UVV photometric system. Using them and comparing the brightness of the other stars against Vega, a color value for that star could be determined. Think about a ruler where Vega is the 0 point for all colors. If a star is dimmer than Vega when observed with one of the three filters in the UVV in Johnson, its magnitude becomes a positive value. If you then observe Vega using these same filters with other observatories, you can establish a 0 point for that observatory, and then you can compare your data with that of other astronomers worldwide. Using a star like Vega, an A0 main sequence type star was not arbitrary. Astronomers believe that a star of this kind will not have a disk or a source of reddening, making it an excellent candidate to calibrate observations of all wavelengths. However, the more they observed it, the more they suspected it had a disk. In 1984, the Infrared Astronomical Satellite, or IRAS, confirmed that Vega had a disk. Later on, between 2005 and 2020, the NASA Spitzer Space Telescope, the Caltech Submillimeter Observatory Mauna Kea in Hawaii, and the Atacama Large Millimeter Submillimeter Array, or ALMA in Chile, map out the disk, identifying two main rings of dust around Vega. The outermost ring appears to be a large asteroid belt, probably populated by large asteroid bodies analogous to our own Kuiper belt. With Caltech and ALMA observations, astronomers studied the emission of grains of about 1 millimeter in size. They found that these are concentrated in three different locations. Using ALMA in particular, astronomers proposed the idea of a disk with a chain of closely spaced planets, with an outermost planet of a mass greater than 6 Earth masses at about 70 astronomical units, or 70 times the distance Earth-Sun. All of these planets within the inner edge of the outer belt. However, more observations were needed, so using the combined power of HST and JWST, astronomers could take a more detailed view of the warm dust disk that surrounds Vega. JWST reveals the infrared glow from a disk of particles the size of sand, while the Hubble captures an outer halo of this disk with particles no bigger than the consistency of smoke reflecting starlight. The observations revealed that the Kuiper belt analogous ring, that it is between 80 to 170 astronomical units, coincided with the planetesimal disk that was captured before by ALMA. The inner part is filled with warm debris that shines most efficiently at the mid-infrared that JWST observes. The JWST observations also revealed that Vega has a disk incredibly smooth, with a shallow gap or flux dip at 60 astronomical units from the central star. So when astronomers compare this system with that of Fomalhaut, another closest star of similar age and temperature as Vega, they found that unlike Vega, Fomalhaut shows three nested debris belts, indicating that planets must be forming there. Furthermore, in Fomalhaut, the light is confined to the narrow outer debris belt, while in Vega has a far more extended distribution. The difference, hence, indicates that there is a variety of disk fates, some of which will not form giant planets like Jupiter and Saturn. But let's not move to conclusions that fast. Although Fomalhaut is about the same distance, age, and temperature as Vega, it is colder. This makes it difficult to conclude if the formation of planets depends on the environment where the star formed, or if the star itself is responsible for the difference. In the future, we will see more studies of this type of stars and learn more about what defines the formation of planets and their size distribution. If you like the information in this channel, please don't forget to subscribe or also visit my website.